on this paper, we have examples of add, subtract, multiply, divide, and solve all in one place so that you can have all of your different types of problems together. So, when you multiply, you need to factor both the numerator and denominator. Circle that, both the numerator and the denominator. On adding and subtracting, you don't factor both. That's what some people did, and then they couldn't combine like terms, and then they couldn't get the right answer. So it's on multiply and divide that you factor both. So when you have a problem like this, we've gotten pretty good at factoring trinomials, finding the factors of 6 that add up to 5, finding the factors of 12 that add up to 7. But what about this binomial? Do you remember how to factor x squared minus 16? 16 is a perfect square number. What's the square root of 16? And so that will, the x squared minus 16 will factor into x plus 4 and x minus 4. So would you write down this factored form on your page? So after you factor, then what do you do next? Please use your pencil very lightly here so you can see these examples. Don't scribble it out so much so that you can't see what was already written there. So this cancels out. Do I have an x plus 2 on the bottom to cancel out? Do I have an x plus 4 on the bottom to cancel out? Do I have an x minus 4 to cancel out? And then, what's left in our answer? Can you cancel the x's like that? You cannot, because the adding glue is holding these together. That is your reduced answer. Can you solve for x? No, because the original problem didn't have any equal sign in it, so you cannot solve for x. You're just reducing it as much as you possibly can. I would also like to caution you, some people wrote this step so messy that once they canceled out, they couldn't see what was left. So you need to write at least well enough so that you can see what's left to be in the answer. So what about dividing? What do you do for dividing? You factor both the numerators and you flip the second term. I would probably I always do the flipping the second term first so that I don't forget. The first thing you need to do is take this term and flip it upside down. When you flip it upside down, you no longer have a division sign. When you flip it upside down, you now have a multiplication sign. Copy that down on your paper, please. Once you flip it upside down, then you factor it. And yesterday we had something like this in one of our problems, and a lot of people had trouble factoring it. This is a binomial. This isn't a perfect square, so how do you factor a binomial that's not a perfect square? Is there something that divides 2 and 6? Well, 2. And do they both have an x? And so you would factor out a 2x out of this denominator. And when you factor out a 2x, you have x plus 3. When you have a binomial that's not a difference of 2 squares, it's not a perfect square, you look for a GCF to factor out. So then you factor it all out and cancel. So what cancels? X plus 3 cancels with x plus 3. Is there anything to cancel x plus 1? And the x plus 2 cancels. And show what is left. Now, stop and look before I say that's the answer. Is there anything else that can cancel? Is there any adding glue in here? And so these x's can cancel. Does 2 divide into 4? And so that's the final answer. I could have canceled that over there, but I didn't to make a point. Some of you got a final answer, but you didn't check it and ask yourself, does this reduce anymore? The final answer has to be reduced as much as it possibly can. Is there any way to just reduce 2? Nope, it's all the way reduced. So our next example is on adding. So on adding, you can see there's more steps because adding's a little tougher, but we factor only the denominator. Again, this is the mistake some people made when we were on the adding problems. They continue to factor the numerator also, and then you can't combine like terms because you can't tell which is like terms when you have it factored out. So we factor only the denominator. So will this denominator right here factor? What divides 5 and 15? And so we factor out a 5. Now, we have to find the least common denominator. The least common denominator has an x minus 3 in it. The least common denominator has a 5 in it. I already have an x minus 3. Now, does this denominator right here match the LCD? It does not. What is missing? 5. So I am going to need to have a 5 in my denominator. But I can't just multiply the denominator by 5. In order to keep my expression equal, I have to multiply by 5 over 5, because what's 5 over 5 equal to? I'm multiplying by 1, and it's not going to change the value. It's just going to make it match up. And so when I multiply that, that's going to be 5x plus 10 plus the 8 that's already up there. And it's all going to be over the common denominator. Instead of writing it with two separate denominators, the denominators are the same. That's what common denominator means. So I just write it over the same common denominator, and then I can combine like terms. So, can I cancel the 5s? No, because the 5 on the bottom doesn't have any adding glue, but this 5 has the 5x is together with the adding glue with the 18. So you cannot cancel anything. That is the final answer. But you factor only the denominator on adding and subtracting and solving. Next, we have a subtraction example. Same as addition, so you factor the denominators. Well, these denominators don't factor. So, next, I need to find the LCD. So the LCD is going to have the x plus 2 in it and the x plus 5. Then I have to make this denominator match that denominator? What am I going to have to multiply this by so it's going to match this denominator? X plus 5. What am I going to have to multiply this by so it's going to match that one? The x plus 2. And so that's what I did right there. Copy that down on. Then what's next? I need to multiply the 4 times the x and the 4 times the 5. Now, this is subtraction. I would strongly suggest that you change subtraction to adding a negative. Subtraction is the same as adding a negative, but if you will change it to adding a negative, you're much less likely to make a sign mistake, because this would be negative 5x, and what is this number right here going to be? What kind of 10? Positive or negative 10? If you don't change subtraction to adding a negative, you will probably miss that sign right there. And this is all over the same common denominator. Then we combine like terms, and that's going to be a 10 over the common denominator. Nothing else will cancel. And then last, we have some solving problems. Now, I did not type these notes on the top of this page, because if I had typed these notes, what would I put first? Up here in the top right-hand corner on this solving page, write factor the denominator first. Right up here on the back, top right-hand corner, factor the denominators first. On add, subtract, and solve, you factor the denominators first. Well, these denominators have already been factored for us. And so now on this problem number 1, all we need to do is start canceling the denominators. So how are we going to cancel the denominators? Now, by the way, why didn't I do that? Oh, let me write it down. How am I going to cancel this? So I'm going to cancel the denominators. Why didn't I cancel the denominators on the adding and subtracting problems to make that easier? Did they have an equal sign? You can cancel the denominators because there's an equal sign, and so I can multiply this on both sides of the equal sign. I can't do that on adding and subtracting expressions because there wasn't any equal sign. That's what makes it different. And so that's going to cancel. And so what do I have left? So I have an x minus 20 left, plus 100 over the x equals minus x plus 10 when you distribute the negative 1. Now what do I need to cancel? Need to cancel the x, so what do I multiply by x? The correct answer is everything. I have to multiply every single term by an x. I have to multiply every single term by an x so that I can cancel out that x. So that's going to give me an x squared minus 20x plus 100 equals minus x squared plus 10x. At this point, do you see a quadratic equation? Do you see that x is squared? If x is squared, I have to zero out one of these sides so that I can have it equal to 0 so that I can factor it. Cancel, 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 cancel. If it is quadratic, it has to be equal to 0 so that you can factor it. I do not want to start this by factoring 2 times 100 and finding the factors of 200. Do you notice that these are all even? So I am going to factor out a 2, so it's going to be easier to factor. So now I need the factors of 50. The factors of 50 that are going to add up to 15 would be 5 and 10. So this is going to be x minus 10, x minus 5 equals 0. So what are my answers? Are those my answers? Well, what about this? What does it say? Can x not equal 10 and equal 10 at the same time? So is this an answer? This cannot be an answer. This is extraneous. And so my answer is x equals 5. So I have one solution and one extraneous answer. On the next problem, the first thing you do is factor the denominators. So, can you factor the denominators on problem number 2? To solve, the first thing you need to do is factor this denominator, and so when you factor this denominator, this is what you get. And now I need to cancel the denominators. You can multiply by the first denominator and then the second denominator, but you will save a step if you multiply by the biggest denominator first. X plus 7, x minus 4. X plus 7, x minus 4. X plus x minus 4. Multiply every single term, and if you multiply by the biggest denominator instead of the first denominator, you will save a step. Because, of course, this will all cancel. But so will this. And so will that. And so what is left after I've done all that canceling? I have an x minus 4 times 2 plus x plus 7 equals 11. You could have gone ahead and distributed that if you wanted to, but when I distribute that, I will get 2x minus 8 plus x plus 7 equals 11. At this point, do I have any x squareds? It's not quadratic. I don't make it equal to 0. I combine like terms. Those are on the same side of the equal sign, so they add up. And I continue solving. What do I do with a minus 1? So, what is x equal to? Oh, really? What does it say up here? X cannot equal 4, because if I had a 4, that would make that denominator go to 0. So is that a solution? What is that? That is an extraneous answer, so what goes up there in the solution? No solution, because I only had one answer and it was extraneous. Now, at this point, I had my students in my previous class period start working on their assignment, and almost everybody messed up problem number 1, so I'm going to help you with that. This is problem number 1 on worksheet 10-6. Now, the denominators don't need to be factored, so I just go ahead and start canceling out the first denominator. What are you going to multiply by? So I'm going to multiply this by 2x, and I'm going to multiply this by 2x, and I'm going to multiply this by 2x. Okay, and so the reason I multiply by 2x is so that this will cancel. So we're going to have 1 plus 6x plus 7 equals minus 2x over x. And then what? What are we going to cancel out next? X plus 7 plus 7, x plus 7, x plus 7. Cancel, cancel. So this is going to be x plus 7 plus 6x equals what? Negative 2x squared minus 14x over x. No. No. That's the mistake. You can eventually get to the right answer, but it's going to be a whole heck of a lot harder, because is there any adding glue in this part right here? What should I do with that x? And so then what will this be? Doesn't that look a whole lot easier than what I wrote down before? Go ahead and cancel that x, and then from here, it shouldn't be too difficult to solve. Let's see. We need to combine our like terms. We need to get the x's together. Nine x plus 7 equals negative 14. Then what are we going to do? We had a 9x plus 7 equals a negative 14. 9x equals negative 21. Now what? Can we have a fraction answer? Yeah, we can. That particular fraction will reduce by 3. And so that is your final answer. It is possible. So what does x not equal to? X does not equal to 0, and x does not equal to negative 7, and there is no extraneous solution. So many people in my first period class made problem number 1 much more difficult than it needed to be because they didn't cancel that x. So, I decided I would prefer these turned in together. So I want 1 through 9 on the green paper and 1 through 6 on the gold paper, due at the beginning of class tomorrow.